Your Android phone is running slower than it should be, and the reason is not your phone's age, not its processor, not the number of apps you have installed, and not anything that requires a factory reset or a trip to a phone repair shop to fix. The reason is a collection of settings that are enabled by default on virtually every Android device sold, regardless of manufacturer, settings that were turned on during the setup process or during app installations that you tapped through without reading, settings that are running continuously in the background of your device right now, consuming processing power, consuming RAM, consuming battery, and consuming the network bandwidth that your apps need to function at the speed they are capable of. Turning these settings off takes under 15 minutes. The performance difference is immediate, measurable, and significant enough that people who have done this describe the experience as feeling like they received a new phone. That description is not hyperbole. It is an accurate account of what happens when you remove the hidden load that default Android settings place on hardware that was designed to be fast and has been systematically slowed by the software configuration it shipped with. The first setting to address is one that most Android users have never seen and that Google buries in a developer-oriented menu that requires a specific sequence of taps to unlock. It is called animation scale, and it controls the speed at which your phone renders the visual transitions between screens, between apps, and between system states. When you tap an app to open it, your phone displays an animation, the app expanding from its icon to fill the screen. When you press the back button, another animation plays as the screen slides or fades to the previous state. When you switch between apps, animations play. These animations exist to make the interface feel polished and to give users visual feedback about what is happening on the device. They serve a legitimate purpose. They also consume time. Real measurable time during which your processor is rendering frames of animation rather than running the app you're trying to use. And the default speed at which Android plays these animations is deliberately slow, set not to the speed that your processor can render them, but to the speed that interface designers decided feels visually satisfying. Your phone is capable of displaying these animations much faster, or of skipping them entirely. The difference in perceived responsiveness is dramatic. To access the animation scale settings, you need to first unlock the Developer Options menu. Open your phone's Settings application and scroll down to About Phone. Within About Phone, find the entry for build number. Tap on build number 7 times in rapid succession. After the 7th tap, a message will appear confirming that Developer Options have been enabled. Go back to the main Settings menu and scroll down. You will now see Developer Options as a new entry in the list. Open Developer Options and scroll down until you find the Drawing section, which contains 3 entries: Window Animation Scale, Transition Animation Scale, and Animator Duration Scale. Each of these is set to 1x by default, meaning animations play at the speed the system designers chose. Tap each one and change it to 0.5x, which makes animations play at twice the speed, or to off, which eliminates the animation entirely. The difference between 1x and 0.56 is the difference between a phone that feels sluggish and a phone that feels instant. Every tap, every transition, every app open and close happens at double the visual speed, which means you spend less time waiting for animations to complete before the phone responds to your next input. The background process limit is the second setting in Developer Options that has an immediate impact on performance, and that requires deliberate configuration rather than simply adjustment of a default value. Also located in Developer Options, the background process limit controls how many processes Android allows to run simultaneously in the background when those processes are not actively being used. By default, Android is set to the standard limit, which means the system decides how many background processes to allow based on available RAM and a set of priority rules that tend to be permissive about allowing processes to persist in the background. Changing this to no background processes, or at most 4 processes. Depending on how aggressively you want to manage background activity, frees RAM that those background processes were occupying and reduces the scheduling load on your processor. The trade-off is that apps that have been in the background will need to reload their state when you return to them rather than resuming instantly, which adds a second or two to the process of switching between frequently used apps. For most users, this trade-off is favorable. The apps they are actively using run faster, and the brief reload time when returning to a backgrounded app is less noticeable than the persistent sluggishness that excessive background processes produce. Google Play Services is the most significant background process consuming resources on nearly every Android device, and it is a process that most users do not know exists and cannot easily examine or control through normal settings menus. Google Play Services is the framework that allows other apps to use Google's APIs. the location services, the authentication systems, the push notification infrastructure, and the dozens of other background services that apps request permission to use when you install them. Google Play. Services runs continuously, updates itself automatically, and performs functions on behalf of every app that has been granted access to its capabilities. It is also one of the most significant consumers of battery and processing resources on Android devices, running background tasks at frequencies and with resource consumption that the normal battery and performance optimization tools available to users do not effectively surface or control. The most direct intervention available to ordinary users for managing Google Play Services resource consumption is through the battery optimization settings that Android provides for individual apps. Go to Settings, then Apps, then find Google Play Services in the app list, tap on it, then on Battery, and you will see the current battery optimization status. If it is set to unrestricted, which is the default for system apps on many Android devices, Google Play Services is exempted from the battery optimization framework that Android applies to other apps and is permitted to run its background tasks at whatever frequency its own internal schedule demands without the throttling that optimization would apply. Changing this to optimized allows the Android battery optimization framework to manage Google Play Services background task timing in ways that reduce resource consumption without eliminating the services it provides. The sync settings for Google accounts and for individual app accounts represent another category of continuous background activity that consumes resources, consumes network bandwidth, and consumes battery in ways that most users have not deliberately configured and would not choose to configure as liberally as the defaults have set them. Android's background sync framework allows apps and services to periodically check for updates, new email, new calendar events, new contacts, updated app data, and synchronize those updates to the device without any user action. This is genuinely useful for keeping your information current. The defaults for sync frequency are set to intervals that prioritize data currency over resource conservation, meaning that sync operations are occurring more frequently than most users' actual needs require, and consuming resources throughout the day for data updates that the user would not notice being 15 or 30 minutes delayed. To review and manage sync settings, go to Settings, then Accounts. For each account listed, Google accounts, Microsoft accounts, social media accounts, and any other accounts whose apps participate in Android's sync framework, tap on the account and examine the sync settings for each data type. You will see toggles for syncing contacts, calendar, email, app data, and other categories. Disable sync for any category whose data you do not need, kept current on the device. If you access your work calendar exclusively through its dedicated app, and not through the Android calendar system, disabling calendar sync for your work account eliminates background operations that provide no benefit to your actual usage pattern. For categories where you do use the sync data, consider whether the default sync frequency is actually necessary for your needs, or whether less frequent syncs would serve you as well while consuming fewer resources. The location services configuration on most Android devices is set to a level of permissiveness and frequency that serves the interests of the apps, requesting location data more than it serves the interests of the user, whose battery and processing resources are being consumed to provide that data. Location determination on Android devices, particularly when using high accuracy mode that combines GPS, Wi-Fi positioning, and cellular network positioning, is one of the most resource-intensive operations the device performs. Allowing numerous apps to access location continuously in the background, which is the default for apps that have requested and been granted background location permission, means T-location system is running continuously, consuming GPS radio power, consuming processor cycles for position calculation, and consuming battery at rates that are measurable and significant. Go to Settings, then Location, then App Permissions. This view shows every app that has been granted location access and the specific permission level each app has been granted. Allow all the time, allow only. While using the app, ask every time or deny. Review this list carefully. The default state of this list on most Android devices that have been used normally for several months reflects the permissions that were granted during app installation flows that presented the permission request at a moment when the user was focused on completing the installation rather than on evaluating whether background location access was genuinely necessary for the app's function. For most apps, always on location, access is not necessary for their core function. Change permissions to allow only. While using the app for every app that does not have a specific and understood need for background location access, such as navigation apps that need to continue tracking your position while running in the background during active navigation. This change reduces the frequency with which the location system is activated by background app requests, and correspondingly reduces the processor and battery consumption associated with those activations. The notification system is both a user experience issue and a performance issue, and the default notification permissions that Android grants to apps during installation contribute to background activity that consumes resources beyond the obvious visible cost of the notifications themselves. Each app that is permitted to send notifications maintains a connection to the push notification infrastructure, typically Google's Firebase cloud messaging system that allows the app's servers to deliver notification content to the device. This connection requires background network activity to maintain, background processing to receive and process incoming notification, payloads, and system resources to display the notification and manage the notification history and the notification shade, apps that send notifications at high frequency. Social media apps, news apps, messaging apps, email apps generate continuous background activity that compounds across all the apps with notification permission to create a persistent background load on the device. Go to Settings, then Notifications, then App Settings or App Notifications, depending on your Android version. This view shows every app with notification permission. For each app, you can see and control which notification categories are allowed and how those notifications are presented. Disable notifications entirely for apps whose notifications you do not find valuable. The apps you check deliberately when you choose to, rather than apps that need to actively solicit your attention to be useful. For apps where you want to retain some notifications, review the specific notification categories and disable the ones that produce notifications you routinely dismiss without acting on. This is a calibration process that requires honest assessment of which notifications you actually find useful versus which you have simply habituated to dismissing, and the result of that assessment for most users is a significant reduction in the number of apps with active notification permission. The storage performance issue is separate from the RAM and processor issues addressed by the previous settings, but contributes to the sluggishness that accumulates on Android devices over time in a way that interacts with all of those settings. Android's file system performance degrades as storage fills, not gradually and proportionally, but with a threshold effect, where performance drops more significantly when storage occupancy exceeds approximately 80% of total capacity. The mechanism involves the file system's need to find contiguous free space for new writes, which becomes increasingly time-consuming as the proportion of free space decreases, and what free space exists is increasingly fragmented. If your device's storage is above 70% full, the file system overhead of storage operations is contributing to the overall performance degradation that the other settings are also producing. The cache that individual apps accumulate over time contributes to storage occupancy without contributing to app functionality in most cases. App cache is temporary data that apps store to speed up future operations. Cached images so they load faster. Cached search results so repeated queries return faster. Cached map tiles so recently viewed areas display without network requests. Cache serves a legitimate purpose, and some of it represents genuine performance investment worth retaining. But app caches grow without bound, if not actively managed, and can accumulate to sizes that consume significant storage. A social media app used daily for a year can accumulate multiple gigabytes of cached images and data whose benefit in load time reduction is marginal compared to the storage and file system overhead cost of maintaining them. Go to Settings, then Apps, and for each significant app, tap on Storage and Cache. You will see the current cache size. For apps with cache sizes above 100 megabytes, clearing the cache, not the data, which would remove your login and preferences, but only the cache, recovers storage immediately and typically produces no noticeable degradation in app performance, because the cache simply rebuilds from current network content during subsequent use. The navigation to clear the cache for each individual app is tedious, and some Android manufacturers include a storage management tool in the device's storage settings that allows clearing all app caches simultaneously, which is worth using if your device includes it. The adaptive battery feature that Google introduced in Android 9, and that has been present in every subsequent version, is a system-level optimization that uses machine learning to predict which apps you are likely to use in the near future, and restricts background activity for apps predicted to be unused. The feature is genuinely effective at reducing background activity and extending battery life, and it should be enabled if your device has it, which you can verify by going to Settings, then Battery, and checking for adaptive battery in the list of battery management features. If it is present and not enabled, enabling it allows the machine learning framework to progressively restrict the background activity of apps you rarely use, which reduces the cumulative background load without requiring you to manually configure background restrictions for each individual app. The combination of changes described here, animation scale reduction, background process limit configuration, Google Play Services battery optimization, account sync review, location permission audit, notification permission reduction, cache clearing, and adaptive battery enablement, addresses the settings and configurations that collectively produce the performance gap between what your Android device is capable of and what it is currently delivering. None of these changes requires rooting your device. None of them requires installing third-party software. None of them involves any modification that cannot be reversed if you decide to restore a default setting. They require navigating to settings menus that are more deeply buried than they should be for settings whose impact on device performance is as significant as these are. And they require spending 15 to 20 minutes making deliberate choices about settings that were made automatically and permissively during the device setup and app installation processes. The performance improvement from this process is not the doubling that the simplified summary suggests for every device in every situation. On some devices that are already well optimized, or that have been actively managed by their owners, the improvement will be more modest. On devices that have been used for a year or more with default settings, that have accumulated significant numbers of apps with notification and background activity permissions, and that have storage approaching or exceeding 80% capacity, the improvement from working through this process systematically is dramatic enough that the doubling description is not unreasonable as a characterization of the subjective experience of using the device after versus before. Your Android phone was built to be fast. The default settings it shipped with were not designed with your phone's performance as the primary optimization target. They were designed with app developer interests, advertising infrastructure interests, and Google's own data collection interests as significant factors alongside, but not always, subordinate to user experience. Taking 15 minutes to reconfigure those defaults toward your actual usage patterns and your actual performance preferences is 15 minutes of recovering the phone you paid for from the configuration that serves everyone else's interests at your expense. Turn these settings off. Your phone's speed will reflect what the hardware was actually built to deliver,